Okay, before I start working through some of those problems on the review, I just wanted to show you this page on the different forms that you have and the different formulas that you're going to be using to find whatever various parts they may be asking you to find. So let's go ahead and dig into the problems. So remember, questions 1 and 2 go together. It says to write in vertex form. So the first thing we're going to need to do, I haven't actually shown you this, but you should be able to find all this information anyway. All right, so this right here is going to open down because I've got a -2 in the front. The vertex, I'm going to have to find the axis of symmetry first. I'm going to do -b over 2a. B is already -4, so I'm going to do +4 over 2 times -2. That's going to give me 4 over -4, so -1. So the axis of symmetry is x equals -1. Remember, axis is the x. Vertex, I'm going to go ahead and plug that in. So -2 times -1 squared minus 4 times -1 plus 7. All right, this is the stuff we did on Tuesday. So -2 times, I'm going to do exponents first because order of operations, that has to come first. So this is -2 times 1. And -2 times 1 is -2. -4 times -1 is +4 plus 7. If I go ahead and add all of that together, that should give me 9. So my vertex, the x from my vertex comes from the axis of symmetry, that's -1, and the y comes from the 9 out there. All right, the y-intercept, we already know that comes from the equation, that's 0, 7. The roots, I don't know unless I graph those, so for now I'm just going to leave those blank. You could graph, well, we'll see an example of that when we can talk about that later, so for now we'll just leave that blank. Domain is going to be all real numbers, and range, because it's opening down, this is y is less than or equal to, and we pull the range value from the y part of the vertex, so y is less than or equal to 9. Now, this whole part about writing in vertex form, now that I have the vertex, this really isn't that hard. I know the vertex, and I know that the pattern out here is -2, so my equation in vertex form is y equals -2. Inside's the opposite, so x plus 1 squared. Outside's the same, so plus 9. And there is my equation in vertex form. All right, let's look at 3, 4. We're going to do this one in vertex form as well, so just another practice of the same thing. This one is going to open up because I've got a positive x squared there in the front. Remember, I have to find axis of symmetry next, so -b over 2a, that's going to give me -9 over 2 times 1, which is -4.5. I know that's a decimal. You're going to be fine. All right, x equals -4.5. You can use a calculator on this one. Plug in for the vertex. I'm going to do -4.5. Ooh, -4.5 squared plus 9 times -4.5 plus 14. And I'm going to go ahead and use a calculator to simplify that. And I got -6.25, all right? So that's going to make my vertex -4.5 from the axis of symmetry, -6.25 from when I plugged it in. Y-intercept comes from the equation out here. It's going to be 0, 14. Roots, don't know those yet. Domain, all real numbers. Range, y is greater than or equal to this time because we're opening up. -6.25 from the vertex. And then again, to write this in vertex form, I've got the pattern in the front's just a 1, so I'm not going to use anything. Y equals x, inside's the opposite, plus 4.5 squared, outside's the same, minus 6.25. And there is my vertex form. All right, question 5, 6 here. We're going to write in standard form this time. So let's go ahead and name everything that we can name without having to work it out, which really should be everything. Okay, this is going to open up because I have a positive number out here in the very front. Vertex, inside's the opposite, outside's the same because we're in vertex form. Axis of symmetry is the x from the vertex, so x equals -6. The y-intercept, remember y-intercept is 0, comma something, so I can plug 0 in for the x here, which is just going to give me 6 squared plus 9. That's 36 plus 9, which is going to be 47. So my y-intercept here is 47. All right, roots, I don't know those yet, so I'm just going to leave that blank. Domain is all real numbers. Range, y opening up, greater than or equal to 9 from the y part of the vertex. Now to change this into standard form, this one's a little trickier. We actually do have to multiply this out. So the first thing I have to do, right, I have exponents here and I have addition. So the first thing I have to do is the exponent, x plus 6 times x plus 6. Remember, you have to write it twice. All right, that's x squared plus 6x, first, outside, inside, last, plus 6x plus 36. And then we'll bring down any other numbers we have. So in the front here, we just have a 1 that's multiplying. That's not going to change anything. On the outside, we have a plus 9. So I'm just going to go ahead and combine like terms since I don't have anything to distribute. And this is going to give me a final answer of y equals x squared plus 12x plus 47. The most important thing that you need to be able to do for your test is naming all of this information. We're going to work some more on writing back and forth, but naming the information is the most important part for your test. All right, and let's go ahead and look then at 7 and 8. This time, standard form again. So we're going to, again, I'm going to name all the information I can first. This opens up because it's positive in the front. Vertex, don't know that yet. Axis of symmetry, I can find that, but not quite yet. Y-intercept, I can find that. Remember, the y-intercept is we're plugging in 0 for these x's. So that's 0 minus 8, which is negative 8, and 0 minus 4, which is negative 4. So that's going to give me that my y-intercept here is positive 32. So I'm going to name that 0, 32. The roots are what's easy from this equation. They're just opposite of what we see. So these roots are going to be positive 8, 0, and positive 4, 0. All right, domain, all real numbers. Range, I know range is y is greater than or equal to, but I don't know the value of what yet because I don't know the axis of symmetry in the vertex. Remember from today, we talked about how to find axis of symmetry if these roots are at, one's at 4, 6, 7, 8, and the other one's at 8, and the axis of symmetry must be here at 6. That's what's in the middle. So the axis is x equals 6. And then to find the vertex, we're just going to plug that in. So to find the vertex, I'm going to plug 6 in this time because that's the axis of symmetry. That's the x value. That's going to give me negative 2, and right, because 6 minus 8 is negative 2, and 6 minus 4 is positive 2. So when I multiply that, I'm going to get negative 4. So my vertex is 6, negative 4. Okay, to change this over into standard form, if I wanted to, I would just need to really multiply this out. And we did this together today. So we're just going to FOIL that out, distribute, right? That's going to give me x squared minus 4x. And then I'm going to distribute the negative 8 minus 8x plus 32. That's going to give me a final standard form as y equals x squared minus 12x plus 32. All right, let's look at the next page. So now we're focusing, we can name all these same things, and I will just to kind of show you what you need to know, but really we're just going to focus on getting all that information on a graph. So if you've stuck with me so far, you should be in a really good place for tomorrow. All right, so this is in standard form. I go ahead and graph everything I can see right away, so I know right away that there's a y-intercept at negative 6. I'll go ahead and plot that. I know I need to find my axis of symmetry. That's negative b over 2a. So b is already negative 4, so I'm going to use positive 4 over 2 times 2. That's 4 over 4, which is just 1. So my axis of symmetry is here at 1. When I draw this axis line, I can go ahead and draw the matching point on the other side, right? And then to find my vertex, some of you can use maybe logical reasoning skills to find the vertex, but if you aren't sure, the best thing to do is to plug that in. So I'm going to plug 1 from the axis of symmetry in, minus 4 times 1 minus 6. It's going to give me 2 times 1 squared is 1, so that's 2 minus 4 minus 6, which is going to give me negative 8 in the end. So if I go ahead and plot that point, right, that's 1, negative 8 down here. If I wanted to get some more points to graph, remember the pattern here is 2. So instead of the 1, 3, 5, 7, I'm going to be multiplying this top part by 2 over 1. So I'm going to go up 2 over 1, which I've already done. And then the next step is going to be up 6 over 1. So if I count that, up 6 over 1. And and the same on the other side. And coincidentally, those give me two good roots. So on this, you could actually name the roots there. If nothing else, you should be able to see that you have two real roots here. All right, let's look at the next question. Question 10, this is vertex form. So inside's the opposite, outside's the same. That's going to be a vertex of 1, -8. So I'm going to go ahead and plot that, 1, -8. Again, my pattern is 2. So 1, 3, 5, 7 over 1. I'm going to multiply this top part by 2. So it's going to give me up 2 over 1. And then up 6 over 1. And look at that. This is the same graph twice. Oh, plotted that wrong. All right. So there you go. There's your graph. All right. Last question. This one's in factored form, so I know that they're going to be giving me the roots right away. So I'm going to have roots at -3 and -1. -1, -3. I know that that's going to, just if I split the middle, that's going to make my axis of symmetry at -2. I also can go ahead and see that the y-intercept is going to be 3 times 1. So 3 is going to be the y-intercept out here in the front. That will give me another matching point on this side. And then to find my vertex, some of you can use the pattern and figure out where your vertex is supposed to be. It's going to be right here because that's what would give you 1 and then 3. But just so you know the algebra behind it, to get that vertex, I'm going to plug -2 because that's my axis of symmetry, remember? I'm going to plug -2 in up here. All right, so -2 plus 3 is 1 times -2 plus 1 is -1. -1 times 1 is -1. That's where we're getting this ordered pair of -2, -1 for the vertex value. All right, and then we can just go ahead and graph there. All right, question 12, what makes an equation quadratic? X squared. The shape is like a U shape, and this is called a parabola. You just need to recognize all that terminology. Okay, question, let's see, up here at the top, we're just going to justify each of the rules here, work these out. Tomorrow you will have numbers, or you should, at least I think, have numbers, but you need to be aware of these. So remember, if you have it squared, that just means you have to write it twice. You can't, there's no, I mean, there is a shortcut here, but you're probably going to be better off just writing it twice. A times A is A squared. A times B is AB. B times A, you can write BA, but I just always write it in alphabetical order. B times B is B squared. So the final answer here is A squared plus 2AB. That's because you're adding 1 plus 1, right? This 1 plus 1. And then plus B squared. Remember, when it's the same thing twice, the middle doubles. That's why it's this plus 2. Okay, B is going to be very similar. You can work that out in the same way, and you should get A squared minus 2AB plus B squared. So same thing, the first number and the last number square, but the middle, right, this middle part is just going to double. This last one is an example of what we call conjugates. It's the exact same thing, except one's positive and one's negative. So when we do that, there is a shortcut. I'm going to multiply everything out and then remind you of the shortcut. So this is A squared minus AB plus AB when I distribute the positive B minus B squared. Remember, in conjugates, the middle cancels out. So you're left with A squared minus B squared. Also with conjugates, remember, you should have a subtraction sign here in the middle every time, and that's always going to happen because we're always going to have a positive number times a negative number. We talked about that in class. All right, this set of questions down here. Draw and label each of the 3 options for a parabola and how it can hit. So remember, that's just in your notes. This is 2 real. A double is when it touches and turns. And then no real or 2 imaginary is when we're not hitting the x-axis at all. An example of conjugates, we already talked about that. You can give any example that you want to. Remember, when you multiply them, the middle is going to cancel out. A rectangle's length is 3 less than twice its width. All right, so I don't know the width. I'll call it W. The length is 3 less than twice the width. So that's twice the width minus 3. If I want to find the area, I just multiply those things together. So W times 2W minus 3. And you can leave it just like that. If you want to find the perimeter, we're going to add all the sides. So you can either fill that in or note there's two sides that have a width of W, right? I have this side on the left and the one on the right. Plus, there's two that are the top and the bottom that are this 2W minus 3. So remember, perimeter is when you add, and that you should have 4 total. 2 that match the left and right, 2 that match the top and bottom. Areas when you're going to multiply. And you shouldn't do any more than you are asked to do. So don't try to simplify unless it tells you you have to. All right, write the expression for the sum of 3 consecutive odd numbers. So consecutive odd numbers, remember the first number is x. The next odd number is x plus 2. Remember, it's tricky, right? But odd numbers skip count, so it's x plus 2. The next one's going to be x plus 4. All right, this says an expression for the sum, so that just means we're adding those together. So I'm just going to put plus signs in between each of those sets. Last question on this page, which of the following functions is a quadratic function? It says select all. Remember, quadratic just means I'm looking for x squared. So it looks like D has an x squared, even though that didn't copy well. B has an x squared. And the rest of those are all examples of linear because they're just x and y. That's super important for you to know for your EOC, by the way, to be able to distinguish between the different kinds. All right, this is the page I told you at the top. You should be using your calculator to solve that. So I'm going to show you. You all know when I say use the calculator, I mean use y equals. So that's what I'm looking for. All right, so this first question, they give me a function to use. It says that the trampoline is steps from 15 feet above the ground to a trampoline that's 13 feet below. So the trampoline itself, if she's at 15 right now, she's 15 feet off the ground and the trampoline is 13 feet down. That means the trampoline itself is still 2 feet off the ground. So that's what we're looking for, is where are we 2 feet off the ground. So I'm going to show you what I got in my calculator the first time. All right, and that's a little dark and hard to see, but the first time I did this, it looks like by 1 second, we're already at -1. So I need to kind of zoom in on my calculator because that's not what I'm looking for. I need a more accurate answer. So I'm going to go ahead and change the settings in my calculator. I'm going to the table setting. I still want it to count at 0 because that's when time is going to start. But this time, I'm going to count by 0.1 seconds so that I can see maybe more specifically when she's going to hit that 2-foot mark. All right, and when I do that, that definitely gives me a better picture. I can see that somewhere around 0.9 seconds is where she's going to hit something around 2 feet. So that's going to be your answer here, is around. And we're just estimating here because we don't have a way to give a better answer. So we're just going to say around 0.9 seconds because it does ask when. All right, so let's do something similar for the second question. All right, this time I did happen to keep my calculator in the same settings, so I'm still looking at making it count by 0.1 seconds. And this question is asking, so before I show you what my calculator is giving me, this question says, this is talking about a shark jumping out of the water, and how long is the shark out of the water? So the shark is going to start, like at 0 time they're in the water, and the shark is going to do something like this. So to figure out how long the shark is in the water, I'm looking for this other point. I know I'm looking in the table, but I'm looking for when the height of the shark is 0. So like x is going to be time, and I'm looking for y, which is height, and I want to find when y is 0 because that would indicate that the shark is hitting the water again. So let me show you what my calculator gives me. Okay, so this is a series of screenshots from my calculator, but notice that you do have this one part of the calculator that's going to give you 0 right here. I don't want that one because that's where the shark is starting, right? That's 0, 0, that's the starting point. So I'm looking for where he lands. I notice to begin with that the shark is going up. Notice the values are increasing and then we're coming back down. So it looks like somewhere between 1.1 and 1.2 is where he's going to hit the water. And then I just changed my values to count by 0.01s this time so I could get even closer, and it looks like somewhere between 1.12 and 1.13. And if I had to take a guess, this is just my mathematical guess, I would say the answer is 1.125 seconds. We're going to talk about how to solve that a little bit more specifically next week though. Okay, questions 1 and 2 down here at the bottom, again, I told you to solve those using your calculator. So this is just saying, when does this function equal -6? So I'm going to type that function into my calculator and look for which x value in the table is going to give me -6. So I'm looking for that x value. Similarly, on the second question, I'm typing this in y equals, and I'm looking for which x value is going to give me, this time I want it to equal 0. So I'm trying to find which x value or values, right? It's probably going to be two different values that you're going to find that give you those answers. So let me do that in the calculator and I'll tell you what you should be getting. All right, so on this first one, I'm going to show you a better way to solve this probably next week, to be perfectly honest with you. But somewhere, I found in my table it's somewhere between -1.8 and -1.7 and +1.8 and +1.7. You might have even said between -2 and -1 and between +1 and +2. The second one gives you a little bit better answers because there are some exact answers there, 2 and -6. All right, let's look at this last question here. Okay, so let's look at these individually. I'm assuming that all of these questions with A are referring to just the g of x because it's the only one that has like an A in the equation. I'm assuming that for f of x, the A is just 1 there because they haven't given us anything. So part A is kind of confusing. This true or false question, A is greater than 1. Well, g of x opens down, so I know that's not true. That's going to be false because g is opening downward. A is less than 0, that's going to be true because I just said that A must be negative because G is down. And I'll just draw that so you can kind of see where I'm coming from. A is greater than 0. Again, we said that that's false. That doesn't make any sense because we're going upside down. Now, is A greater than 0? Sorry, less than 0 or less than 1? So this is a question of, this is kind of reads a little bit weird, but basically, is the number that you have, the value of the number, less than 1 or less than 0? Okay, this is definitely false. You can cross D out altogether. You don't need to worry about that. Really what E is asking, is this have a slope bigger than 1 or less than 1? If you think about it, if it had a slope bigger than 1, you'd go like down 2 over 1. Down 6 over 1, right? That makes it really super skinny. It's like it stretches it out. So really this has a fractional slope, which is what this says, a number that's less than 1. So this is going to be true because fraction is going to make you go down 1/2 over 1, where a whole number, right, that's going to make it really wide, where a whole number is going to make you go down 2 over 1. It's going to make it really skinny. That's a little hard to kind of wrap your head around. F and G share the same vertex. That's true. They both share the origin. They share an axis of symmetry. That's also true. They both share x equals 0. The graphs share a minimum or a maximum. Both of these are going to be false because f of x has a minimum where g of x has a maximum because they're opening different directions, even though they have the same vertex. That's a pretty challenging question if you stuck with me on that. All right, I love this last question. And if I say I love it, means you might see something similar to it. What's the maximum height of the baseball? So this doesn't even require a calculator. We can just look right at the graph and kind of come up with what we need to there. What's the maximum height? So I'm looking for this max height here. Looks like it's happening around 3 seconds, and I think that appears to match up with 144. So I'm going to say maximum height is 144 feet. The time that it reached that height was about 3 seconds. When does the ball hit the ground? So this is the ball leaving the ground. There's the ball hitting the ground. So it's going to hit the ground after 6 seconds. Find an equation. So that part's going to be a little bit challenging. The part that you probably aren't going to know, and this is fine, I need you to know that you have a negative number in the front. You're not going to know what you're multiplying, what number you're actually multiplying out there, but you will know that it's negative. And then we can just use vertex form to write like an equivalent expression here. So we're going to have t minus, inside's the opposite, so t minus 3, because my vertex is 3, 1, 44. plus 144. And don't forget that squared. A few of you were doing that today. So if you can get at least that far, I'm good with that. We can talk about how to get the number on the outside there a little bit later. And then question D, a second baseball is modeled by this function, this g of x equation that they give us. Which baseball has a greater maximum height? Which one is in the air for the longest? So if we go ahead and we can either graph that or use the table in the calculator. I do know to find the maximum height, I can look at the vertex. This one has a vertex of 4,256. So this one definitely has a higher height. Right, the other one's only going up 144. This is 256. And then which one's going to be in the air for the longest? My initial guess is going to probably be to say this one, because it takes 4 seconds to get to its highest height, which means it's probably going to take 4 seconds to come back down. So my guess is that this one's going to be in the air for 8 seconds, but I would need to use my calculator to verify that. All right, and it actually did work out there. It won't always work out that way, so do always check that in your calculator, but it looks like at 8 seconds here, we're back to 0. So that means we're hitting the ground after 8 seconds. So obviously this second ball is going to go higher and be in the air longer. All right.